Today is our 10th News from the Lab, and we're starting a mini-series on CERN knowledge transfer. Now, you're all aware that CERN technology and accelerators, detectors, and computing has found its way into a wide range of applications outside the field of high-energy physics. And today we're going to be looking at the bigger picture, but in following editions, we'll be taking a deep dive into areas ranging from healthcare, quantum, environment, aerospace, and also entrepreneurship. Now, today I'm delighted to introduce our moderator, CERN alumna Liselott Fredriksson, who works as an analyst at the International Energy Agency in Paris. Her role focuses on facilitating international collaboration on energy research and technology, as well as advancing gender diversity within the energy sector. Prior to this, Liselott worked for 2 years on knowledge transfer activities at CERN. Her earlier work experiences focused mainly on research and innovation policy. Now, Liselott has studied economics and business administration at Hanken School of Economics in her native country, Finland.
Thank you so much, Rachel, for your introduction, and super happy to be with you all here tonight. And today's talk presents really on such an exciting, diverse, and dynamic area of CERN's work, so I'm really excited to hear more. So it's my great pleasure to introduce you today's speaker, Dols, who's heading the business development and entrepreneurship section at CERN. He's responsible for building industrial strategic partnerships, innovation alliances, and entrepreneurship activities. And the aim of his work is to accelerate innovation together with the most innovative companies and startups through leveraging the wide range of hardware and software technologies at CERN. And previously, Han has been driving innovation in various management roles and industries, and he has a background in physics, business development, and marketing strategy. He did his studies in physics and computer science at TU Delft, and he's also an alumni of IMD, University of California, and the Frankfurt School of Management and Finance. So warmly welcome, Han, and the floor is yours.
Thank you. Thank you very much for the invitation. I must say it was really nice to have this opportunity to present to all of you for a couple of reasons. Because first of all, my career path has been kind of reversed to many of you because of this alumni audience. Many of you have worked at CERN and now moved to industry or moved to other institutes. For me, it was the opposite. So I've been working in industry for 20 years. More than 20 years, and then I moved to CERN. So for me, I have experienced probably the same transition, but then in the other order. And the other thing, what I'd like to already say immediately, that of course at CERN, and that's also what my talk is about, you will see, is it's about creating impact on society. That's really, of course, what we care about. Is also what my talk is about. So yes, we want to accelerate innovation. And then I mean innovation that has positive impact on society, but we cannot do that alone. We need industry for that. And I hope that maybe some of you are working in a position where you feel you get inspired by this, and maybe you can reach out later and we can see if we can do collaborative R&D projects together. Because in the end, it takes two to tango, as I always say. So what I hope to achieve in this talk is to give you an impression, first of all, of how we do then this knowledge transfer thing. What exactly is it, and how would it look like from a company perspective, regardless if the company is small or large, or maybe even whether it can be an institute. I'd like to give you a feel of the process. So how do we collaborate with industry in order to help them innovate and accelerate their innovation? So I hope to achieve that. And as Rachel mentioned, there will be follow-up talks in the series where we can really go much more in depth into various topics. So the beauty of this is normally when I give this talk, I need to explain what CERN does and what kind of things we aim to achieve. I think I can skip that. Basically, you all are familiar with the CERN mission. There is, of course, research, education, and training, but I think the most important one, the most important pillar for knowledge transfer is the technology and innovation that is happening at CERN. So, of course, we all do this because we want to understand better properties of fundamental physics, but in order to do that, we are constantly being challenged to build new technology, to find new engineering solutions for problems. And so we have to innovate already for the purpose of our own high energy physics experiments. And this means that there is a lot of technology at CERN that is developed specifically for this high energy physics field. So as you can imagine, this goes, from accelerator technology, like superconducting magnets, the material science that you need for that, the electronics that you need in the detectors, but also the entire software side. And I'm not talking just about the, let's say, the software that you need to analyze your results, let's say the anomaly detection capabilities, maybe the machine learning that you use in that, but also the software that we use to control this huge machine. So if I zoom out a bit, you have to think about this like we're sitting on this huge pile of technology. And what we want to do is think ourselves, which other societal challenges could be benefiting from these technologies. And that is what we try to achieve in our knowledge transfer group. So we really try to think, can we find industry that can benefit from this specific examples of know-how and technologies that we have, in order for them to find solutions that have positive impact on society. So there are some historic examples that you all probably heard many times. So I know this sounds boring, but just to make sure that we've talked about it, of course, we're very proud that once the World Wide Web was there, and that this fantastic gentleman has worked on a sort of a tracker ball with optical sensors that was later used under the mouse, and that even the touchpad, has found some very early, let's say, examples of application at CERN. So we want to have more of this. We want to think, what can we do to find more applications of CERN technology in areas that have nothing to do with high energy physics, but that are relevant to society? And we do this in various ways. So first of all, we try to create collaborations with industry, as I said. And this can be collaborations with startups, with large companies, but also sometimes with institutes, in order to team up on bringing technologies to the market. We also have entrepreneurship activity. There are quite some startups out there in the member states, so in different countries, that could benefit from CERN technology, that could use a CERN technology to build a startup around. And of course, in terms of events, we sometimes organize events specifically around a theme or in a specific country to help reach out to industry. As you can see in the bottom here, intellectual property management is of course important, because CERN is a special place. There are many institutes working together at CERN. So we really need to think of, if something is invented, who is the owner, how does it work, how can we best regulate this? Should we file a patent on this, yes or no? Because with patents, we don't want to stop others, but sometimes industry prefers if we have a patent on technology, because it makes it more interesting for them to adopt the technology. Support for CERN personnel, we often get questions from inventors who have an idea and say, hey, how should I organize this, or working with other institutes, universities, to get more feeling for how they can team up. Open source, we have a very strong open source policy. We care a lot about open source, and has even created an open source hardware policy. And finally, funding. As a team, we also continuously try to help, let's say, inventors at CERN to get funding to explore new opportunities for all the technologies I showed you outside the field of high energy physics. So it's interesting, if you talk to companies and you ask them, what makes you now interested to team up with CERN? How do you look at CERN? And what they typically say is they see us as a sort of a trusted non-commercial innovation partner, because obviously CERN is not a commercial entity. So that somehow gives them a sort of a trustworthy feeling that what we do can help them in their innovation, especially if it relates to topics that have a strong societal impact. So we have asked ourselves the question, what should we now focus on? Because we don't have a huge team, so we need to really think what topics are most interesting. And we have had discussions and looked into the interest in member states, so in different countries, of domains that seem to be most attractive to further innovate from a European perspective, but also that have somehow a link to the technology at CERN. And that's how we have identified these 5 areas. So healthcare. So it's obvious to think that, you know, we have technology in the field of radioisotopes, for example, accelerators, but also detectors, so imaging, that could really have already shown to be very helpful in healthcare. And environment, we have quite some know-how on, for example, superconductive cables that can be used to transport energy. We have used fiber optic sensors to measure humidity, as you can see in this example. Then digital, obviously, we have a lot of data at CERN. So if you think, if I sometimes summarize it, I think we're very good in finding a needle in a haystack. So we're really good in finding very small signals into huge amounts of data, which can, of course, be used by others as well. I'll talk about it later. Aerospace, obviously, the conditions we have in our LHC, so in our machine, they look a bit at space. It's very cold, it's vacuum, there is radiation. So if you talk about testing electronics for radiation, for example, we can really make a difference there and help industry to do that. And finally, quantum. So quantum is interesting because it's a sort of a double-edged sword. On one hand, we like to use quantum technology ourselves to analyze our data. And that's, I think, something that's not happening today, but you know, we are trying as an organization to think of how can quantum play a role there. And that's why also the Quantum Technology Initiative has started. But on the other hand, we also may have technology that can help others to create a quantum computer or a quantum sensor or a quantum network. So we specifically look for technology that we have in the hardware domain that can contribute to that. So if I zoom out, so you see here that we want, as CERN, to get more collaboration going on, more innovations with industry in these 5 areas. So how do we then do this? I think what is interesting to realize is that on the left side, you see all the technology, right? So technology and accelerators, detectors, computing, as I showed before. On the right side, you have these, let's say, domain areas, these markets. Now, if we would be a company, then what you would do is we would always start on the market side. You would think of, wait a second, healthcare. What are the unmet needs in healthcare? What do doctors need? What problems are not solved there? What are the big challenges for hospitals in Europe? And you would start based on those unmet needs to, let's say, set the direction for your R&D programs and drive your innovation activities. Now, in reality at CERN, we don't, let's say, create technology based on these unmet needs, because the technologies on the left-hand side you see there, they are really driven by our needs in high-energy physics. We make detectors with the goal to find more Higgs bosons, to put it a bit simplistic. So how do you strategically deal with this? Because, you know, we're not a company, so we don't innovate for, let's say, a market need. But on the other hand, we have a whole bunch of technology that might find its way there. So I think the answer is that we have come up with a sort of a hybrid strategy, because the typical technology push doesn't work. Because of course you can take a specific element of an accelerator and ask who needs this, but that is not maximally effective. And purely let's say the market pool, as a term is used in marketing, also doesn't apply. So we have a sort of a hybrid approach. So on one hand, we do scout for technologies internally. We are constantly in connection with experts across the lab to think, what are they working on that really is unique, that is different from what's already out there, that might find an application in the market. So we do a lot of technology scouting internally. But then on the other side of that, we also look to unmet needs in these 5 areas. So we do try to get a feeling by talking to industry and to institutes about what is it now that they really need. And on top of that, we need to create technical dossiers. So once there is a technology identified at CERN that could be interesting, we need to make sure that the intellectual property, who owns this, how is it organized, is it well documented, do we have test facilities, do we have maybe prototypes that companies can play with. So we need to build up this, let's say, this tech dossier. But on the other hand, we also need to then ask ourselves a question, what value could you generate with this technology? So more from a business angle, what problem could you solve with this technology in one of those 5 domains? So we have worked on creating value propositions for all the technologies that we have in order to make the connection with industry a bit more simple. And then finally, it's all about people. As I said in the beginning of my presentation, it takes 2 to tango here. So we need to find the right experts that also have appetite to start working on projects that have, a specific connection with the technology. But on the other hand, we need to also scout for the right partners working in industry, startups, maybe large collaborations, maybe SMEs that are already in a specific market and where the CERN technology could help to solve a problem that they have. So this hybrid strategy, I think, works well, but it's hard work. And I give you a flavor of the process. So if you want to shape an innovation partnership, and I will give you examples in a few seconds, it starts, of course, with discovery. You need to get together and help serendipity a little bit. Sometimes if you are in a networking event, or let's say in a trade show or in a medical conference, you might have coffee with somebody who coincidentally is working on something that coincidentally could benefit from CERN technology. So what we try to do, we try to help serendipity by organizing discovery events. So we can organize for a company what's called a Discovery Day program that is centered around the needs of a company. And in that event, in that, let's say, program, we do typically talk to people who lead innovation, people who are have management positions in R&D, that have a good overview and understanding of the needs and the R&D pipeline in the company. And hopefully that gives a bit of a sense of where there could be a mutual interest. Once that's identified, so imagine that we work with a company, I take the example in automotive, and we think we can work together on a LiDAR laser, for LiDAR equipment. Then you have to really see, okay, how would such a project look like? What are the timeline, the resources we need? What are the contribution of both partners? So what will CERN contribute? What will the company contribute? How will you then manage the resulting IP? So you have to shape that innovation partnership. And finally, you need to transform this into a formalized partnership, which can be, let's say, supported by a license agreement or a collaborative research contract or a collaborative R&D agreement. So I won't talk too much about it, but I think it makes it a bit more concrete to see these examples here. So sometimes it feels a bit abstract, and people ask me, but how then does this look like, such a contract or such a collaboration? So basically, there are a couple of tastes here. So if you have interest in a CERN technology that is really something that is well defined and it's owned by CERN, we could give a license. So we do give licenses on specific CERN technology, in case it's not open source, to companies, so they can further manufacture and commercialize the technology. And other examples, we give consultancy. We help a company to address a specific problem. So when there is know-how that is relevant from CERN, not a specific technology, but really the know-how around the technology, then a consultancy approach would fit much better. There are some examples, not too much, where we do contract research, where we really, let's say, allow the company to outsource part of its development to CERN. And finally, and that's what we see most, is collaborative R&D. So that is when you want to do research and development on a topic that has mutual interest, where you say, wait a second, we are working in this field of, let's say, lasers for our own needs. The company is also working in lasers because they want to create this LiDAR laser for a car, for example. Let's team up. And that is a sort of a model that we see more and more, but it also requires companies to have a sort of an open innovation mindset. So let me ask a question. I don't know if you feel comfortable shouting out what you think, but how much time do you think it takes to create an R&D partnership? Let you think about it for a few seconds. Well, I can tell you that it typically takes between 1 to 2 years, because you need to first understand from CERN's perspective which companies would be most interested to work with us, or the company needs to reach out to CERN to figure out what they want. So you first have a whole dialogue to find the right people. And then you need to see, okay, how can we shape a project together? Once the project is shaped, then you need to make sure that you can get the resource allocation right. Then you need to all map that into in a contract where you need to go through a whole process of negotiation. So it really takes time, but it's worthwhile. And this is also normal, because also when I worked in industry, as Lieselot said, I worked before I joined CERN 20 years in industry in innovation roles. It's very normal that really a decent R&D partnership, it takes a year to create this. So let me give you some examples so you understand a bit better the concept I just explained. So here you see an example of collaborative R&D. So where basically there are two institutes, Med Ostrom and Knau, so in Austria and Italy, that are providing hadron therapy to patients to help treat specific cases of cancer. And I think one of the next series, we will go much deeper into this. So I'm just touching the surface here. But what is interesting to realize, if you looked at this picture, you might say, yeah, but where does CERN now fit in here? I don't see any, where does CERN fit in? But in the room next to this room, here, literally in this hospital, this room looks a bit like this. And that is, maybe it's good that you don't realize as a patient, this is really the machine in the hospital where you see, again, a circle with accelerators where particles are being accelerated just like CERN. So you can imagine there is a lot of overlap in technology, in accelerator technology, detector technology, the instruments that you use to control this machine, how you monitor the quality of the beam, etc., that is very close to what we do at CERN. So this is a very concrete case of a collaborative R&D project that has resulted into these two beautiful facilities where hadron therapy is being offered to patients. A totally different example, and on purpose I took a totally different example because there is a very wide range of applications, is a kind of a consultancy project we did with Bundesdruckerei, and Bundesdruckerei, that's the German state-owned company who prints the euros, but also who makes passports and who also works on identity management software solutions to make sure that I can prove that I am me, kind of, and that nobody can hack my passport, if you will. So here we have been working with a team under leadership of what was called the chief visionary officer at Bundesdruckerei, who had the objective to look, let's say, 10, 20 years ahead. How will a passport look like 10 years ahead? And what technology could you use in there? And is there any CERN technology or any concepts that we have that could help there? So we have been working with them and had a couple of very interesting workshops around cryptography, about material science, which materials could you use in passports, and also about data handling, to help them and to inspire them a bit in new ways of thinking on these topics. So this is really a sort of a unique example where you see there was not a CERN technology, it was also not the intention that you could put in a passport the next day, but really to use the creativity of experts at CERN and the vast area of technologies we have to think out of the box. So that's also what we do with companies if they're kind of stuck on a specific problem. Another example of collaborative R&D is our collaboration with Zenziact, which is from Volvo company. And it's interesting here to realize that at CERN, of course, we, as you know, as CERN alumni, we generate a lot of data. And we need to throw away a lot of data, more than 95%, in order to make this manageable. So we need to be very strict in understanding which part we throw away, because if we throw away the wrong part of the data, we won't find any new physics. So we use machine learning, and we're also exploring how we can use machine learning in the future for that. And we need to do this very fast. So we need to think of algorithms and electronics that you can use to, in a very short amount of time, execute machine learning algorithms. Now, let's say this know-how that we have built up, that was also interesting for companies like Volvo, because also these cars get more and more sensors and they generate a lot of data. So they also want to have solutions that are very efficient in processing this data in a very short amount of time, and also in a way that doesn't consume too much energy. So this collaboration has been running for a couple of years, where we had a few fellows at CERN working on this, because it has really a sort of a mutual interest. We both wanted to see how can we get to a combination of software and hardware that would allow us to do machine learning faster. And it's a great example of a collaborative R&D program. Another example on collaborative R&D, again, a totally different use case, is on the finance markets. So as you can imagine, when you're trading commodities, so when you're trading, let's say, grains or seeds or oil or potatoes, the commodity market is huge, and these transactions are almost all the time now done automated. And regulators who control these markets, they find it sometimes very difficult to really monitor if there is no if no fraud is being, let's say, detected in these huge commodity markets. And the difficulty is that it all happens in a very short amount of time. So one example of this is that regulators who want to detect what is called spoofing, that's a specific way how to, let's say, influence the market to your own advantage. And of course, that is illegal, but it's being done by algorithms within, let's say, a few milliseconds. So it's very difficult to detect this. Now, as I said in the beginning, CERN is actually pretty good in detecting a needle in a haystack. So we've used here CERN's software, Root in this case, and also the expertise behind that, to team up with these finance experts to help, in the end, national banks and regulators to be better capable of detecting fraud. Finally, another use case, which is really contract research. So what I talked about earlier, where let's say part of the R&D is outsourced to CERN. We do also work with the European Space Agency for development of a high energy beam to test the capability of electronics to withstand radiation. So here you see a satellite. Very recently, we have been launching the satellite together with our partners, so we're very proud about that, in order to really understand the effect of radiation on electronics, so also others can benefit from the test facilities we have at CERN. In this context, there is also something I'd like to bring under your attention, is that, so we have these 5 areas, and in some cases we decide to start a sort of a program, and here we have created a program, the CERN Innovation Program on Environmental Applications, where we really have challenged the CERN experts across all the technologies to think about which technologies do we now have at CERN that somehow could contribute to our big challenges in environment. And we started that a bit more than a year ago to shape this program. And it's interesting to see the right area of application ideas that this has resulted in. To give you a bit of a flavor, the 4 areas that we think are most close to CERN's know-how on superconductivity, on magnets, on vacuum, is the area on energy, so the production of energy and the distribution and storage of energy. And you can imagine that we have know-how on maybe materials that can be used in energy fusion, know-how on how to bring large amounts of current from A to B using superconductive cables. So that's the area, I think, where we might have a lot of connection with industry. Then the whole area of sustainability and green science, so the power management, heat management, industrial processes related to that. Then on the top right, mobility. As you can imagine, next to electric cars, there may be one day electric airplanes, and electric airplanes might benefit from some technologies at CERN that we're also discussing at the moment with various industrial players. But that also goes for maybe shipping, like huge ships that have kind of a bad reputation about the amount of SOx and NOx that they bring in the atmosphere. Maybe we can help them with those kind of challenges. And finally, everything that has to do with monitoring of air quality and modeling of that, we believe also we have some connections there. I could talk about it for an hour, but I have a colleague at CERN, Enrico Chesta was leading this, and there will be a separate session organized for this also as part of this mini-series. There are a few projects already ongoing that happened even before this project that indicates that there is a clear link to energy. So, for example, we did once a consultancy project for Tokamak Energy in the UK because they wanted to understand better how energy, let's say the electric field and the magnetic field, is influenced in various components when you build a fusion magnet. So we did various simulations of the currents and magnetic fields that are used in these so-called tokamaks. And another project that we recently started with ABB has been really designed such that we better understand all the components that we use in our cooling and ventilation system and make a digital twin in order to improve the electricity, let's say, footprint. So of course we want to consume less electricity. Quite some electricity is being used in cooling and ventilation. So the better we can monitor where this energy is going and make scenarios to improve it, the higher the likelihood is that we need less energy. So it's a very nice project that we're in the middle of today. So far you have seen typically examples of large companies, big projects, but it's also good to realize that we do work a lot with startups and that we create spin-offs resulting from CERN activities and CERN technologies. And here you see about 40 of them. So let me give you a quick flavor of those. So we have, for example, a startup who is using Medipix detector to look at to study, let's say, the various layers of paint in order to get a better understanding of cultural heritage of paintings and of you know, trying to address questions. Is it how was it painted? What kind of paint was used? What does it say about the age of the painting, etc. Another startup leveraged some of the digital archive technology that we developed at CERN. It's a startup called Tint. And we gave them a license on our technology. And it's really cool to see where they now have found customers. So there are tons of large, let's say, libraries that now benefit from this. I think it includes the New York Times, some very nice examples of where this Tint company that has licensed this digital archive technology from CERN has been applying this. And then finally, there is this beautiful example of a company called Mars Bioimaging that has been using, let's say, specific detector technology that we have to make a sort of a color X-ray. So with these CERN detectors, we can not only monitor each single particle that hits the detector, but we can also measure the energy of that particle. And then you can kind of color code that amount of energy, so you can make a color X-ray. So it's really cool to see here. And I think here is a little example where you see a wrist. So you can get a very high resolution of it. So you see all the little microstructures. But it's interesting, normally when you do X-ray, you see indeed bone. But there is a lot of soft tissue around bone, like the blood vessels and the connecting tissues in between that you cannot model. But with this technology, you can make that also visible in the same scan. So I think that is a beautiful example of how CERN technology found its way into a medical application. And now, as we speak, there is one of these machines also installed here in Lausanne at the CHUV for further clinical research. So on the startups, to close with that topic, a little sneak preview. So we do start a new program to look for startups in the member states that could use CERN technology. We have a separate presentation on that as well. So one of the talks in this series will be about entrepreneurship, and we do have now the ambition to pre-select specific technologies that we think are interesting for startups, and we are going to actively scout with partners in the member states for startups that can be more successful using these CERN technologies. So I'm looking at the time. I think in a couple of minutes left. So what are now the key lessons learned when you want to innovate together? So I've talked a bit about the process, about how we try to focus on specific markets, how we find partners. First of all, you have to realize that CERN is strong in the extremes of the technology scale. So there are tons of pieces of software out there that can handle large volumes. But at CERN, we have 1 exabyte of data that we manage. And there are also tons of examples of materials that can be used in cold conditions. But we have a machine of 27 kilometers long at 1.9 Kelvin. So we really feel comfortable in the extremes. So if a company or an institute wants to, let's say, benefit from this know-how, it really makes sense to reach out to us. If you reach out to us, we also have learned that you really need passionate experts on both sides to succeed. Because reality is a company has a much shorter focus, let's say, and is much more application oriented. At CERN, we have a much longer horizon, and we are much more scientifically driven. So you really need passionate experts on both sides to bridge that, let's say, gap, because there is a sort of a gap in language and culture, which you need to just embrace. Finally, I also believe it's good to start with concrete projects and a clear business need. It should really be driven by a business need, otherwise you will not have the commitment from a company to work together. So I typically prefer not to start with a large collaboration about, let's do something together. No, I think it's best if you make it very concrete and formulate what exactly you want to get out of it mutually. As I said, mind the gap in terms of language, culture, and clock speed. And then I think also, and that's also for my 20 years in industry, it takes a bit of courage to innovate. Because if you truly innovate, you're in new territory and you don't know what comes out. So nobody can guarantee that you have a fantastic outcome of a project. That's why you're innovating. But the beauty is magic may happen, as you've seen in examples. And that's also why I think we should sometimes look in a mirror and tell ourselves to be courageous enough to try totally new things. So with that, I'd like to wrap up. So as said in the beginning, if you want to accelerate your innovation with CERN, please contact us.
Yeah, thank you so much, Han, for this great presentation. It's always impressive, I think, to see the breadth of outcomes of the work that you're doing, and there's indeed countless opportunities for CERN can contribute. So Rachel raising her hand.
Yes, just indeed. Thank you. I just wanted to mention that we have an alumni entrepreneurship group. If people are interested in joining that, I've put the link in the chat.
Indeed, thanks for mentioning that.
That's great. And yeah, many ways that you can still connect with CERN, even though you've left it.
Yeah, I think so. As I mentioned here, so of course you can reach out, but on our KT website, kt.cern, you'll get some pointers as to what technology we have, and there are some value propositions there. I think, what I would love is that you help us spread the word that you can do this with CERN, because honestly, most companies I talk to, and which is part of our role to proactively reach out to companies, they tell us, CERN, I thought you're doing something with particles under the ground at CERN. How can I now do something with CERN? Companies don't know. I mean, not all companies do know. So I think that's work for us to improve the visibility of our KT activities, also as Michelle indicated. And we would benefit from some ambassadors like you to help spread the word that this is a possibility which really only aims to create more social positive impact for society.
That's great. And yeah, there are many, I think, exciting stories and examples of how CERN has already done that. So they're, I think, great to carry forward. Right, I think we're reaching the end of this talk, and we wanted to wrap up. So thank you, everyone, for your participation, and I'll hand it over to Rachel for the final words.
Thank you so much. And so thank you to you, Lisa-Lotte, for being such a great moderator, and to you, Han, as well, for such a fascinating talk. I just want to let everybody know that we have in the pipeline, we're hoping to organize in end of November environment, followed by healthcare in January, digital in March, aerospace in May, entrepreneurship in June, and then we think quantum in September. So thanks again, Han. Thanks so much, Lisa-Lotte. And please, everybody, stay connected to alumni.cern for the upcoming dates. Thank you very much.